Hi everyone, this is Adam again. So today I'm going to do trigonometry basically, but it's quite a big chapter, so I'm going to basically stop before we get to the proofs. So I'm going to do everything up until the proofs. Okay. So first of all, the very first thing to do in trigonometry, this is kind of just recap from junior cert, the first few bits. Is just going to be Pythagoras' theorem. Okay. So if we have a right angle triangle like this is A, this is B, and this is C, then A squared plus B squared equals C squared. Hopefully everybody remembers that. So just as an example, let's say we have, this is 13 meters, this is 12 meters, and this is X meters. I want to figure out what X is, this being a right angle. You would say 13 squared is going to be 12 squared plus X squared. So 169 is equal to 144 plus X squared. So X squared is equal to 25. So X is equal to 5. Okay. So that's it. The next bit then is just sine, cos, and tan. Okay. So again, say this is the angle A, this is your right angle. This up here is your long side, or the side opposite the right angle, is the hypotenuse. Hypotenuse. The side that's opposite the angle we're looking at is called the opposite. And the side that's beside the angle A, that's not the hypotenuse. So obviously it's this angle A, there's two sides that are beside it. One's the hypotenuse, the other one is the adjacent. So if I call the adjacent A, the hypotenuse H, and the opposite O, then basically we get that the sine of A is equal to the opposite over the hypotenuse. The cos of A is equal to the adjacent over the hypotenuse, and then the tan of A. So the tan, remember, it's if you watched a couple of differentiation videos, basically tan is just slope, so it's rise over run, so it's the opposite over the adjacent. So if you ever forget what tan is, just remember it's slope. That's all it is. Okay. And also, if we look at the angle B, then the sine of B. So again, you can try and think about what the sine, cos, and tan of B would be. In this case, the sine is going to be A over H. The cos is going to be O over H. And then tan is just going to be A over O. So if you look, sine and cos have been flipped. So they've been kind of changed. So the sine of A is the same thing as the cos of B. And the cos of A is the same thing as the sine of A, which is just interesting to note. That's why sine and cos are basically the same thing. Okay, we'll see in a while when we're graphing it out. It's basically the exact same thing. All right. And then tan is just flipped. So the tan of A is just 1 over tan B. Okay. So that's kind of that. You would have done all that in junior cert. I might just do one little example, but I'd expect this to be fairly obvious. So let's say this is 9 and this is, say, 30 degrees. Figure out X, Y, and say alpha, given that it's an angle. So first of all, I'm going to figure out what X is. So I can say, well, the tan of 30 is going to be the opposite. So the opposite side to this angle is X, divided by the adjacent side. So the adjacent side is the 9. The hypotenuse is Y, so it's the adjacent side I want, so it's 9. The tan of 30 is 1 over root 3. Okay. So this gives me that X is going to be 3 root 3. Great. So that's using one of the tans. Now, I'm going to figure out y by using Pythagoras. You could use a load of different things to figure this out. You could use sine or cos in this case if you wanted, but I'm specifically just going to use Pythagoras just because I can. Okay, just to do another Pythagoras example. So I can say x squared plus 9 squared has to equal y squared. So x squared is going to be 9 times 3. So first of all, you square the 3, you get 9, square the root 3, you get 3, plus 81 is equal to y squared. So y squared is going to be 81 plus 9 times 3 is 27. So y squared is going to be, y is going to be the square root of this plus this is going to be 108. So y is going to be equal to actually sorry, I'm just being a little bit slow. First of all, I can factor a 3 out of it, so it's root 9 times 12. Yeah, so you get a 3, you get a 2, so it's 6 root 3. Root 3 over 2. Yeah, okay, that's fine. Yeah, that's the right answer. So this is then 6 root 3. This is 3 root 3. And then finally, to get alpha, I can just use, say, sine. I can say the sine of alpha is equal to the opposite. The opposite to alpha is 9. Divided by the hypotenuse is 6 root 3. Okay? So this is root 3 over 2. And then alpha is going to be sine minus 1 of root 3 over 2. Like that. Okay? So I'm pretty sure I covered that before. I'm not actually sure what chapter I covered in, but I'm pretty sure I covered why sine goes from this to this. Basically, sine minus 1 is sine inverse. So, sorry, I'm going to just take a step back. So, just in case I haven't explained, because it's definitely been a while since I've done the inverse of sine. So, you get the sine of alpha is equal to root 3 over 2. You take sine inverse on both sides. So, sine minus 1 of sine alpha equals sine minus 1 of root 3 over 2. If you plug the thing on the right into your calculator, the sine minus 1 root 3 over 2, you should get 60 degrees. Okay? Now, again, you can pause the video, but what do you think this is going to turn into? So sine inverse sine of alpha. The answer is alpha. The reason it's alpha is because sine inverse basically undoes sine. So again, I definitely did this somewhere, but the idea is let's say alpha is like, I say a tie. If I'm sine, then say I'm like wrapping the present, and then sine inverse will unwrap it. So what did you start with? You started with a tie, I wrapped it, sine inverse unwrapped it. So what are you left with? A tie. So you started with alpha, you give it to sine, you then give that to sine minus 1, and now you end up with just alpha on its own. Okay? So that's how you do the inverses. Okay? All right. So now it says using trigonometry to solve practical problems. So in the direction, actually, I don't know why that's even there, to be honest. Yeah, I don't think you really care about any of that. Yeah, I don't think you do. Okay, that's fine. So what I can do is I can basically, I'll just do some sort of example, all right? So let's say here, 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 and there. So this, you're going to have a crosshairs here, and this is going to be 50 degrees. This is 225. This is 310. And this is 40 degrees. Basically, what they want to know is, they want to know how far is it from B to C. So what's that then? So if I call this length X, how can I figure it out? Okay, well, first of all, I can say, well, this is 40. So we just did it in a couple of videos ago, but if you didn't watch it, this is a Z here. So this means that these two angles are alternate, and therefore this is 40 degrees. So remember, this is parallel to this. Okay? And therefore, those angles are alternate. So that's 40 degrees. So what I have is I have 40 plus 50, so I have a right angle there. Okay? So what I can say, well, that means that 310 squared is equal to x squared plus 225 squared. So x squared is x is equal to the square root of 310 squared minus 225 squared. So x is approximately equal to 213 meters. And if you're sitting there wondering, how did I know that the hypotenuse was 310? The reason is because the hypotenuse is always opposite the right angle. So the right angle is here. So which side is opposite that? The 310. And that's how I knew that that was the side to be on its own. Okay? And then they also ask you to find an angle ACB. So this angle. So this angle, I can just say that the sine of alpha is equal to 225 over 310. So alpha is equal to the sine minus 1 of 225 over 310. So alpha is equal to 47 degrees. Okay? So that's kind of that. All right, so I don't think those are too bad. Kind of basic, I'd hope, from your junior cert. Okay? So the next thing that I want to do, and some of the unit circle as well and drawing them. Okay, that's fine. All right, so degree and radians. So how do you go from degree to radians and vice versa? So 180 degrees is equal to pi radians. And you might sit there and say, well, what is a radian? So 1 radian is the angle. So 1 radian. If this is a radius, then this would be a radius. Okay, so that's what 1 radian is. Okay? So basically the whole circumference is 2 pi r. And so basically, I hope, which in paper 1 I did a little bit of this, but basically this length here, so L is always equal to the angle in radians, so theta multiplied by r. So that's where the 2 pi comes from, because if I want a full circle, then I go 360 degrees, which is 2 pi. And therefore in this case, the angle is 2 pi. So let's say we have x degrees. How do we go to radians? You multiply it by pi and you divide it by 180. Let's say I have radians, I multiply it by 180 and I divide it by pi. So those are your 2 conversion factors as to which you want to do. Okay? All right. So basically, that's just converting degrees to radians. It's really not that bad. Okay, so one of the questions here, it just says, Dan is a member of a breakdancing club. During a routine, he spins on his head, turning a total of 960 degrees. In which quadrant does the angle 960 terminate? So basically what they're asking is, they're saying, okay, this is the first quadrant, and you always go from right to left. This is the second one, this is the third, and this is the fourth. So then starts here. And remember, you always start from this axis and you always work backwards. Okay, so the same thing as in polar form when you're doing complex numbers. So if I go 360 first, then I go just full circle. So just to be clear, 960, that's equal to 600 plus 360. So after I go 360, I still have 600 left. And I can say that it's actually 240 plus 2 times 360. So there's actually two 360s in 960. So you do one 360, you go again, and then you do 240. So 240 is, there's 90, there's another 90, there's 60. So this is where he ends up. Okay, so he ends up in the third quadrant. Okay? And it says, what is the measure of this angle in radians? So basically convert 960 degrees to radians. Again, you multiply by pi, divide by 180. Okay? And you end up with 16 pi over 3. And that's it. Okay? So hopefully not too bad. Now, the next thing, which is very, very important, is the unit circle. Okay? So basically, the unit circle, what it kind of what it tells you is that an awful lot of proofs kind of come from the unit circle. Okay? And the unit circle, this goes hand in hand with complex numbers. Okay, so after maybe watching this video, if you struggle with complex numbers, go back and watch that video, and these two will start to connect when the complex numbers, when it goes to polar form, they'll start to connect an awful lot. Okay, so the unit circle is basically, you have a circle and the radius is 1 unit. That's it. So you have 1, 0. Sorry, so again, this is y, this is x. You have 0, minus 1, 0, 1, and you have minus 1, 0. And you have a load of other points in there, okay? Now, what you can do is, which is quite interesting, is any point on the circle you can rewrite. So let's say I want this point. And this is the hypotenuse, and that's 1. You can come down and make a right angle and say, okay, well, what are these sides? This side is going to be sine theta, and this side is going to be cos theta. So this is cos theta, sine theta. So in case you're wondering why is polar form equal to cos theta plus I sine theta, it's because your real part, so remember your real part is the x value, is cos, and then your y part, which is the imaginary part, is sine. Okay? And you might say, okay, well, I don't believe you. I don't believe that this side is equal to sine, and I don't believe that that side is equal to cos. Well, what's sine? Sine is the opposite over the hypotenuse. The hypotenuse in this case is 1, so it's just equal to the opposite. So the sine is indeed the opposite. And the same thing with cos, because the hypotenuse is 1. Okay? Which is actually quite interesting. Okay. Now, the next thing to look at is basically they'll ask you, where are sine and cos positive and when are they negative? So, if I ask you, when is sine positive? Remember, you always measure theta from this angle here. Okay? So, cos is always positive here. And it's always negative here. So the x value, so basically if I say when is cos theta positive, you could say cos theta is greater than 0 when theta is basically between, so an element of 0 and pi over 2. So remember, pi over 2 is 90. Okay, so no, sorry, that should be this, or theta is between here and here, because theta can also be down here where this thing is theta. Okay, so it could also be 3 pi over 2 to 2 pi. Okay, and then theta is, and cos theta then is negative all in these values here. Okay, so when theta is an element of pi over 2 to 3 pi over 2. So cos is greater than 0 half the time and then less than 0 half the time. Okay? And then for sine theta is greater than 0 if theta is an element of 0 to pi. And then sine theta is less than 0 if theta is an element of pi to 2 pi. So sine is a little bit nicer. So sine is like the height. So when is the height positive? The height is positive all up here. So from 0 to pi. And then when is it negative? It's just from there to there. Okay? Which is quite nice. And then you might ask, when is 10 positive? Well, remember, 10 is slope. So if I go from here, if I draw a line here, that has a positive slope, which means 10 is greater than 0 here, and it's also greater than 0 here. If I draw a line here, it's negative. So therefore 10 is less than 0 here, and 10 is also less than 0 here. Okay? So sine, cos, and tan are both positive and negative in 2 quadrants each. Okay? And the way you can remember this is cast. Okay? So if I do it out, so you have C, A, S, T. So basically here, cos is the only one that's greater than 0. Here, all of them are greater than 0. Here, only sine is greater than 0. And here, only tan is greater than 0. Okay? So that's it. That's all. Okay? Another thing that they can do is they can basically ask you to write these in surd form. Okay? So basically, what you're kind of doing is like you have kind of nice angles, okay? So like 30, 45, and 60 are all nice angles. So if I asked you to get the cos of, say, 210, and ask you what that is, what you do is you draw out your circle. You would say, okay, where's the cos of 210? So where's 210 degrees? So this is 180 and it's 30. So this is 30 degrees and you're here. They want to know the cos. So they want to know the x value of this. And that's 1. Well, you can just use sine, cos, and tan. You can say, well, the cos of 30 is going to be equal to x. And the cos of 30 is equal to root 3 over 2. Like that, okay? Now, you'll notice that this is negative because it's on the left-hand side. And therefore, it's on the negative side, not the positive. And therefore, the cos of 210 is going to be equal to minus root 3 over 2. Okay? And that's it. Nothing else is kind of important there. Okay? The next thing that I want to do is go over basically graphing these. Okay? So if I graph sine theta, you get something that looks like this. Where this height is 1 and this height is minus 1. So sine always goes from plus 1 to minus 1. This is pi. This is 2 pi. This is 3 pi. This, it reaches a maximum at pi over 2. It reaches a minimum at 3 pi over 2. Okay? So hopefully that all makes sense. The reason sine looks like that is the way you can think of it is, I might just draw a new one again. If you grab your circle and I asked you to kind of plot the heights of it, well, you'd say, okay, so it starts at 0. So here, starts at 0. Then the height increases, 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 and it reaches a maximum height of 1 at an angle of 90 or pi over 2. So it goes up and 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 up, and then it reaches a maximum then at 90 degrees. And then it starts to go down, 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 and reaches 0. So again, goes down, 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 reaches 0. And then the same thing happens on the bottom, and then it just repeats itself. So this is what you would call, so this is the amplitude. The amplitude is equal to 1. Okay, and you could be asked for this. So the range is equal to -1 to 1. So the square bracket, remember, is when you include 1. So can you get 1? Yes, you can. The sine of 90 gives you exactly 1. The sine of 270 gives you exactly -1. Okay? And then the period is equal to 2 pi. The period is basically how long does it take before it repeats? It takes this. Okay? So if you just like kind of kept going, this looks the exact same as this. Basically. Okay? That's kind of the idea there. So the period is just how long does it take for it to repeat. Cost is very similar. It just starts a little bit differently. So the graph of costs starts from this point up here. Like that, and it just keeps going on forever and ever. So again, this is pi over 2. This is pi. 3 pi over 2, so I'm just adding a half every time. And again, it repeats after every 2 pi. So again, it's the top going down. It's at the top, it goes down. So again, this is just, if you look at the x values, the x value starts at 1, it decreases, decreases, decreases until it hits 0. Then it keeps going, goes negative, then goes back to 0, and then goes back to 1. And so then again, this is the exact same. The range is, it goes from -1 to 1, and the period is equal to 2 pi. Now 10 is different. 10 is not the same, okay? 10 looks awful, to be quite blunt about it. It looks like this. So basically, no, that's kind of drawn quite badly. Sorry. It should kind of, yeah, kind of like that. Kind of like this more so. Like that. So it doesn't really go flat. It kind of just keeps going up, you know. So yeah, that's what 10 looks like. Because remember, 10 is like the slope. So if you look at the slope, if you look at the slope here, it's very small, gets bigger, and now it's almost like getting close to infinity as it gets up to here. That's why, because obviously, like a straight line up, you can kind of think as being like plus infinity, minus infinity. So that's why this one actually just goes up to infinity. So the range of this function is actually just everywhere. So the range is just equal to the real number. So it's just equal to everything. And it doesn't really have a range. Okay? And the period equals pi. So this is the one that's a little bit weird. It repeats after every pi, not 2 pi. Okay, just to be clear. Because here, the slope is positive, then it goes negative, and then it goes back to being positive. Because this slope here is the same as the slope up here. So it actually repeats after every 180 degrees, not 360. Which is quite interesting. Okay, so the period, so this is going to be pi over 2. This is pi. 3 pi over 2. 2 pi, on. So it repeats after every pi. Okay, so you can see that's 0, that's pi, it looks the same. Okay, so it just repeats after every pi. Okay, and then let's say they want you to draw say, a sine graph. So they want you to draw sine 3x, and I want you to draw cos x over 2 plus pi. So how would you draw these? So first of all, sine 3x, what does it look like? So what does the 3x do? The 3 basically makes it quicker, which probably makes sense because let's say the 3 wasn't there. Just cross it off for a second. If we just sine x and I said, okay, I want the sine of 30 degrees. What does x have to be for me to have the sine of 30 degrees? 30. But if the 3 is there, now I say, okay, I want the sine of 30 degrees. What does x have to be? 10. So it's actually 3 times quicker. Okay? So this is one of the things that if you have something like sine omega t or cos omega t, then the period t is 2 pi divided by omega. So in this case, sine would look the exact same, or sorry, let's say I put like a 4 here as well. It would look the exact same, just it would be much quicker, okay? And it would go from plus 4 to minus 4, okay? And before, this used to be pi over 2, now it's going to be pi over 6. So you just divide all the things by 3 because it's 3 times quicker, and so on and so on. Now, if I want to do the cos of x over 2 plus pi, like this, then what happens is first of all, I'm just going to draw the cos of x over 2. What would that look like? It would look something like this. So now it's getting twice as slow. So before this used to be pi over 2, now it's pi. Okay? This here used to be 2 pi, and now it's 4 pi. So the period now has become 4 pi. Not 2 pi, so it's doubled because I've halved here. Okay? And remember, adding pi actually shifts it to the left by pi. So I would actually end up with something like this. So it would actually kind of look like a minus sine wave. If you add pi onto it, it kind of looks like a minus sign basically. So it's kind of this part here that I'm graphing. Okay? All right. And that's kind of that. So this would be 2 pi and then this would be 4 pi. Okay. So we have a couple special angles. So yeah, the special angles are just 30, 45 and 60. I've already said that. And they're in your log tables. Okay, so just knowing that they're the special ones is all you need to do. Okay. The next thing is just solving trigonometric equations. So basically it could be something like solve cos theta is equal to minus root 3 over 2. For theta is from 0 to 360. So what you do is, you draw your unit circle. Remember, cos is the x value. So when is the x value equal to minus 3 over 2? It's somewhere over here. So it's going to be there and there. Now remember, I always said if there's a root 3 involved, the angles are either 30 or 60. In this case, it's 30. Okay? But if you didn't know, you would say, well, the cos of theta is equal to this. Grand. So this is theta. That's fine. So this x value here, so remember this is 1 and this is going to be root 3 over 2. You can simply just call this angle alpha and say, well, the cos of alpha is going to be root 3 over 2 divided by 1, which is just root 3 over 2. Alpha then will give you 30 degrees, which is pi over 6. Okay, so in this case, theta is going to be 180 minus 30, which is 150. But theta could also be equal to 180 plus 30. So for this point and this point, you can have 150 degrees or 210. All right. Let's say they want to know the sine theta is equal to a quarter. Like this. Okay. So basically, what I do is again, you draw it out. Sine of a quarter, so the height is a quarter, so it's quite a small angle. But there's two heights on the circle that will give you a quarter. This is theta, this is a quarter, and this is 1. So I can just say that theta is going to be sine minus 1 of a quarter, which is going to be 14.5 degrees, which means this is also 14.5 degrees. So the other theta that would work is going to be 180 minus 14.5, which is going to be 165.5 degrees. So it's either 165 or it's 14.5. So there's two answers that'll give you the same one. Okay? And finally, if they wanted tan theta to equal minus 1 over root 3, so again, unit circle, tan is the opposite over the adjacent. So again, it's minus. It looks something like this. Okay? So it's theta and theta. Okay, well, sorry, this isn't theta, it's this, which is just 180 plus this one. Okay, so I can say, well, I'm just going to redraw it just to make it a little bit nicer. If we just work on alpha here, this is again 1. This is a right angle. The it's 1 over root 3, so tan is minus 1 over root 3. So again, actually, sorry, how do I? Yeah, I'm sorry. I'm just being a little bit stupid. Sorry. So basically, you kind of, because you've taken care of the minus sign, I can basically just look, because as alpha is concerned, it's going up. So you can just say that the tan of alpha. No, sorry. That's really stupid logic. Sorry. If I just start off with tan theta, yeah, just to keep this simple, tan theta is equal to minus 1 over root 3. Theta is tan minus 1 of minus 1 over root 3. Theta is going to be equal to 30 degrees. Okay? So basically, what you have is that you're getting 30. Sorry, no, you wouldn't. You get minus... Would you get minus 30? Yeah, I'm pretty sure if you plug that into your calculator, you're going to get a minus 30, which would give you this angle. But you never want that angle. You always want this angle, and then this one. So this is 30, grand. Theta then would have to be 150. So basically, if you add 180, and then if you add 180 again, you get 330. So sorry, you just plug it into your calculator, you get minus 30. That gives you this angle, but that's not the angle I want. And the reason there's a minus there is because you're going down. So plus angles go kind of this way, minus angles go down. But basically, you know that this is 30 down here. And then obviously this is a straight line, which means the whole thing is 180. So if that's 30, theta has to be 150, and then the other one has to be 330. Okay? All right, I think that's quite a good place to stop before the proofs. So I think I'll leave it there for today. Okay, so thanks very much for tuning in, and I think I'll leave it there, and hopefully I'll finish these fairly soon. But thanks very much for tuning in. I'll talk to you there.